Previously in class, we learned how to solve problems where we had objects that had forces on them, and the forces were always perpendicular to each other. We did masses, accelerations, total accelerations, total force, force of gravity, normal force, and so on. But those forces were always perpendicular. Today I'm going to teach you in this lesson how to handle forces that aren't perpendicular, forces that are at an angle. For instance, let's say I have something like what I pictured up here, a mass of 3 kilograms that is hanging from a ceiling by 2 ropes, and you can see the angles that are given there, 20 degrees for the left-hand rope and 60 degrees above horizontal for the right-hand rope. And so the first thing we're going to do to solve a problem like this, just like any force problem, really any problem in physics, is we're going to start with a picture. And as we talked about before, we're going to start by drawing a free body diagram. So I'm going to take that 3 kilogram box and I'm going to separate it or free it from the rest of the picture. And then I'm going to draw all the forces that are acting on it. So you can probably guess from the picture that there are 3 forces acting on it. 2 forces are tension forces from the ropes, and then the other force is a force of gravity. The force of gravity always points down towards the center of the earth. So there's my force of gravity, and then I've got 2 tension forces. And I'm going to label them tension 1 and tension 2, just so I can keep them straight throughout this. Now the next thing we have to do, after we draw our free body diagram, and again, make sure this is correct. So you may even want to put angles on here. That's a smart thing to do to make sure we have those even in our picture. The next thing we want to do is write what we know about the situation. And we said before that we're going to always start by writing down what all the forces add up together to be. So I'm going to say in this case, the sum of the forces equals the total mass times the total acceleration. But right when you start looking at that, you realize I've got forces here in 2 different directions, actually 3 directions. But I got tension 1 at 20 degrees, tension 2 at 60 degrees, and then the force of gravity is straight down. So this is going to be tough to do 3 different directions. What do you add them together? Do you subtract them? Is this positive? Is this negative? Even though it's up and to the left? So the way that we're going to do this is we're going to split it into x direction and y direction. So I'm going to say, well, let's look at the x forces, and the sum of the forces in the x direction will equal the mass, which of course has no direction, times the the total acceleration in the x direction. So it looks something like that. And then you can also imagine we need to do this same thing for the forces in the y direction. So we're going to have to keep track of our forces in the x and our forces in the y. Accelerations in the x and accelerations in the y. So now when I look back at the problem, I can say, okay, what's happening in the x direction? And then what's happening in the y direction? In the x direction, so this way, is the box accelerating? Well, no, it's at rest. This box is hanging from the ceiling, so this thing is at rest in the x direction. So I can go back to this and I can say, well, the total acceleration in the x direction is 0. That's the total acceleration. And similarly, for the y direction, I can say, well, in the y direction, is it moving up or down? No. Is it accelerating up or down? No. So because it's at rest in the y direction, because it's not accelerating in the y direction, I can say the acceleration is 0 in the y direction. And then I'm just going to simplify this so it's easier for us to look at. And we say that the sum of the forces in the x direction equals 0 newtons. And the sum of the forces in the y direction equals 0 newtons. Well, now the next step, after you've you've written your sum of the forces equation, and then you've described what's happening with that acceleration. You know the total acceleration is 0 because it's not accelerating left or right. And it's not accelerating up or down, so we know the total acceleration in the y direction is 0. So we can say that that is 0 newtons altogether. The sum of the forces in the x direction is also 0 newtons altogether. Well, then we have to say, what are those x forces that I'm summing together? What are the forces that I'm adding together? And when you look at your picture, the first thing you say is there are no x forces, right? Because I've got, this is down, this is up and to the right, this is left and up. So then we go back to this and we say, okay, well we've got to do something with vectors here. I need to take these two vectors and break them into components. So I can take this first tension, I can break it, or the second tension, I can break it into an x component here and a y component going up. And I can do the same thing with the first tension. A negative x, because it's going to the left, and then a positive y, because it's going up. So now we're going to look at the two up y forces and the one down y force, because those three are all vertical. And we'll do that stuff over here on the y. And I've got my x stuff, two x forces, and so those will go here in the x forces. In fact, let's do that. So the sum of the forces in the x direction, this is going to get a little complicated for now, but you'll see in just a second. In the x direction, I have two x forces, one to the right and one to the left. I'm going to call this one force of tension 2 in the x direction. And this one, force of tension 1 in the x direction. Man, that's a lot of letters. So when I write it over here, I'm just going to simplify it a little bit. You don't have to do it this way, but to make it a little simpler to work with, I'm going to just drop the f. I'm going to say that I've got tension 2 in the x direction. And that's to the right. And I've got tension 1 in the x direction. And that's to the left, so I'm going to subtract it. We're adding a negative because it's the opposite direction. So that's T1 in the x direction. And that still equals 0 newtons. Now let's do the same thing for the y values. Again, over here I've got, let's see, force of tension 2 in the y direction and force of tension 1 in the y direction. And I've got two ups, those are both positive, and one down, that'll be our negative. So when I sum up all my forces, I've got three forces. I've got tension 1 in the y plus tension 2 in the y minus force of gravity because it's down. And that still all equals 0 newtons. So all I did is take the sum of the forces and describe what forces I'm adding together. In this case, adding a negative. Same thing here. What are the forces I'm adding together? These two positives because they're both up, and this one down that is negative. Now, if you've done this far, if you've done this much correct so far, the rest is just math. So the physics is done at this point. If you're doing a problem like this, you've got to spend a lot of time making sure your free body diagram is correct and making sure this line is correct. If you get this correct, then you probably get the rest of the problem correct. So now I have to go back and figure out what I'm doing with this thing and then what numbers I can plug in and so on from there. Well, you can start all different places here. I'm going to start with T2 in the x. Then I'm going to write that in terms of angles and so on. So I won't rewrite this every time, but I'll do it here. T2 in the x, that's this guy right here. Right, remember ft2x and t2x are the same thing. I'm going to say, well, this is really, right, let's see, that's cosine. So the cosine of 60 degrees equals the adjacent, so T2x, over the hypotenuse, which in this case is force of tension 2, or I just say T2. And I'm going to rewrite that. So the T2x is going to end up being, T2x is T2 cosine of 60 degrees. And similarly, T1x, that's this over here, is going to be T1 cosine of 20 degrees. And that all adds up to 0 newtons. And now I'm running out of room. There we go. Oops, I forgot my T1. Okay, let's leave that for now and go to this stuff. Now, we can do the same thing for the y stuff. T1y, now instead of using cosine, we're going to use sine because it's opposite over hypotenuse. So T1y is really going to be T1 sine of 20 plus T2y, which is T2 sine of 60, minus the force of gravity, which we learned is the mass of the object times g, which on Earth, of course, is 9.8. Now, at this point, you're saying, that is a mess. I've got two equations, and I've got, let's see, 3 unknowns, 4 unknowns. But it's better than up here. Here I had 2 equations, and I had 5 things I didn't know. But we can continue to plug some stuff in that we know. For instance, over here, I know the mass, and I know g. So I can do T1 sine 20 plus T2 sine 60 equals the mass, which is 3 kilograms, times 9.8 meters per second squared. One of the things I'm going to ask you on the Google form is, why did I not put a negative there? I want you to think about that and then answer, of course, appropriately. Okay, well, again, I don't like this. This kind of seems messy to me. So I'm going to plug some numbers. I'm going to actually put that into my calculator. And I'm going to get T1 sine 20 plus T2 sine 60 equals 3 times 9.8. Which is 29.4. And of course, that's newtons. Okay, now let's look at what we have. We have this equation and this equation. This is true, this is true. It's true from our picture. It's true from our sum of the forces equations. And I have a T2 and a T1, and a T1 and a T2. I have 2 equations and 2 unknowns. And hopefully from math, you remember that if you have the same number of equations as you do unknowns, then you can solve it. So we know at this point it's solvable. We just have to do it now. Well, I'm going to go back to this side and say, okay, I can simplify this a little bit. I've got T2 cosine 60 equals T1 cosine 20. And if I wanted to, I could solve for T2. T2 is T1 times cosine 20 all over cosine 60. And remember, cosines, those are just numbers, right? So I can actually plug that into my calculator and find out what that is. It's going to be some number times T1. I don't know what that number is. So on my calculator, I've got cosine of 20 divided by the cosine of 60. And that gives me 1.88 times T1. Make sure you're in degree mode when you're doing those. Well, that's important because now I can take this and plug it in over here. Right? Wherever I see a T2, I can plug it in for T2 over there. So I've got T1 sine 20 plus, instead of T2, I'm going to put this in, 1.88 T1 times sine of 60 equals 29.4 newtons. Now, at this point, you've got one unknown. You plug everything in. You solve for T1. You can go back to your beginning then. You can say, I know what the tension in these 2 ropes is. This one will be T1. This tension will be T2. And you'll have 2 numerical values. I'm going to leave that for you to solve and again put on the Google form.